Homework 2. 1. Write the expression in the standard form a plus bi. 6 plus 7i in parentheses minus 8 minus 9i in parentheses. Simplify your answer. We're going to start with step 1, which is to distribute the negative into the parentheses. So you'd have negative times 8 and negative times negative 9i. So we can just go ahead and rewrite this. 6 plus 7i minus 8 minus 9i. And again, we want to distribute this negative sign into both terms inside the parentheses. So you have 6 plus 7i, and then negative times 8 is negative 8, negative times negative 9i is positive 9i. Then step 2, combine like terms, group them first. So first we want to group together the like terms. You got 6 and 8 which are like terms, so we could have 6 minus 8, and then 7i and 9i are like terms, so you have plus 7i plus 9i. And then if we combine the like terms, we end up with negative 2 plus 16i. And the last step is to make sure the equation is in standard form, a plus bi, and in this case negative 2 plus 16i, which is what we have right here, is in standard form of a complex number. This right here, negative 2 plus 16i, it's in the a plus bi form. This is your a, negative 2, and then bi is 16i. 2. Subtract 4 minus negative 3 plus 5i in parentheses minus negative 2 minus I in parentheses. So step 1, we have to distribute the negative sign into both parentheses. So let's write down the problem. 4 minus negative 3 plus 5i minus negative 2 minus I. We need to distribute this negative into the first parentheses, and then this negative right here into the second parentheses, into both terms. So you end up with 4 negative times negative 3 is positive 3, negative times 5i is negative 5i, and then negative times a negative 2 is positive 2, negative times a negative I is positive I. Step 2, we need to combine like terms, group them first. So the first thing we want to do is to group these terms. So you got 4 plus 3 plus 2 minus 5i plus I. If we combine the like terms, 4 plus 3 is 7 plus 2 is 9 minus 5i plus I, and then negative 5i plus I is 9 minus 4i. Then step 3, we want to make sure the expression is in standard form a plus bi. In this case, 9 minus 4i is in standard form of a complex number, because the 9 represents the a, and then negative 4i represents the bi. 3. Divide and simplify to the form a plus bi. 7 divided by, or 7 over 4 minus I. Simplify your answer. Type your answer in the form a plus bi. To start, step 1, for this problem you want to get the imaginary number 4 minus I out of the denominator. So this right here, 4 minus I, we want to get that out of the denominator. And to do this, we have to multiply the denominator by its conjugate. The conjugate of every complex number is a minus I, or a minus bi is a plus bi. So the conjugate in this case of 4 minus I is 4 plus I. So if we write our problem, we have 7 over 4 minus I and we would just multiply the numerator and the denominator by 4 plus I, which is the conjugate. And then if we write it again, 7 times 4 plus I, 4 minus I times 4 plus I. Well, we distribute the top. So you have 7 times 4, which is 28. 7 times I, which is plus 7I. And if you notice in the bottom, 4 minus I times 4 plus I is a difference of squares. This is a difference of squares. Because this problem is in the form, it's basically in the form a plus b times a minus b, or in this case, switched around. And that right there is equal to a squared minus b squared. So we can take 4, which is our a value, square it, minus our b value, which is I, and square that, so minus I squared. Then if we simplify that, we have 28 plus 7I 4 squared minus I. 4 squared is 16 minus I squared. And actually I got a few steps ahead of myself. So the first thing we did was to have the conjugate, which is right here, which is step 1. And then the second thing we did was to multiply the numerator and the denominator by 4 plus I. That's what we did right here. We were multiplying the numerator, the top, by 4 plus I, and the bottom also by 4 plus I. And then what we did here, which is the result, is we distributed these terms in the numerator and the denominator, which is step 3, distribute numerator and denominator. And that left us with this value right here, 28 plus 7I over 16 minus I squared. So next, step 4 is to input -1 for all I squared values. So you have 28 plus 7I over 16 minus, input our -1 for -2, so minus 1. And then step 5 is to simplify and reduce the fraction if possible. So we have 28 plus 7I over 16 minus -1 is plus 1, so 17, because 16 plus 1 is 17. And then our last step, step 6, says to split the term into 2 separate fractions. That way the term is in the standard form of a complex number, a plus bi. So we can just split this into 2 fractions. So we have 28 over 17, which doesn't simplify because 17 is a prime number, and then plus 7I over 17, and this doesn't simplify either. So that ends up being our answer, 28 over 17 plus 7I over 17. And then this is our A, plus this right here is our BI. Divide and simplify to the form a plus bi. 60 over I or 60i over 3 plus I. Step 1. For this problem, you want to get the imaginary number 3 plus I, right here, out of the denominator. To do this, multiply the denominator by its conjugate. The conjugate of every complex number is a minus bi is a plus bi. So in this case, the conjugate of 3 plus I is 3 minus I. So 60i over 3 plus I, to get rid of this complex number in the denominator, we need to multiply the numerator by the conjugate, 3 minus I, and also the denominator by the conjugate, 3 minus I. And that's also kind of step 2, is to multiply these items. And then going to step 3, distribute the numerator and denominator and combine like terms. So we want to multiply 60i times 3 minus I over 3 plus I times 3 minus I. We want to multiply 60i times 3 and then 60i times negative I. And if we do that, we get 60i times 3 is 180i, and 60i times negative I is negative 60i squared. And then if we multiply the bottom, 3 plus I, 3 minus I, we'll realize that the bottom term is a difference of squares, which means the bottom is going to be equivalent to a squared minus b squared. In this case, a is represented by 3, so you'd have 3 squared minus b squared, which is I, so it'd be minus I squared. And if we simplify this, we have 180i minus 60i squared over 3 squared is 9 minus I squared. And then step 4, we want to input negative 1 for all I squared values and evaluate. So you have 180i minus 60. Let's input our negative 1 for I squared value, so it's negative 60 times 1 over 9 minus, input our I squared value of negative 1, 9 minus negative 1. And if we evaluate this, 180i minus 60 times negative 1, negative times a negative is a positive, so it's 180i plus 60. And then 9 minus negative 1, a negative times a negative is a positive, so it's 9 plus 1. So we have 180i plus 60 over 10. Step 5 wants us to simplify and reduce the fraction if possible. Well, 10 goes into itself once, 10 goes into 60 6 times, and 10 goes into 180 18 times. So we're left with 18i plus 6 over 1. And if we split this term into two separate fractions, it's really just the same as 18i over 1 plus 6 over 1, which is just the same as 18i plus 6. And again, with step 6, we're splitting the term into two separate fractions. That way the term's in the standard form of a complex number, a plus bi. So we want the I term to the right. So we can just rewrite it as 6 plus 18i. And then 6 is our A term, and then 18i is our B term. And that's our answer, 6 plus 18i. 5. Divide and express the result in standard form. 6i over 8 minus 9i. Simplify your answer. Type your answer in the form a plus bi. Use integers or fractions for any numbers in the expression. So, step 1, for this problem, you want to get the imaginary numbers, 8 minus 9i, which is right here in the denominator. You want to get the imaginary numbers 8 minus 9i out of the denominator. To do this, multiply the denominator by its conjugate, and remember the conjugate of every complex number is a minus bi is a plus bi. So in this situation, the conjugate of 8 minus 9i is 8 plus 9i. So we can go ahead and rewrite the equation, 6i over 8 minus I, and then we're gonna, so we realize that, and then 2, now we need to multiply the numerator and denominator by 8 plus 9i, which is multiplying it by the conjugate. So the numerator and the denominator times 8 plus 9i. And step 3, we need to distribute the numerator and denominator and combine the like terms. So we'd multiply 6i times 8, and then also 6i times 9i. And then we have to do the same thing with the denominator, multiply 8 minus 9i by 8 plus 9i. But let's start with the numerator. 6i times 8 is 48i, and then 6i times 9i is plus 54i squared, and that's over 8 minus 9i minus 9i times 8 plus 9i, and this right here in the bottom should actually be positive 8 minus 9i over 8 plus 9i, and this in the bottom is a difference of squares. It's a difference of squares. Difference of squares is just a squared minus b squared. So in this case, 8 is the a term. So it should be 8 squared. And actually right here it should be minus 9i. So 8 squared, and then it should be minus, it should be 9i squared. And then if we evaluate that, you have 48i plus 54i squared, and then 8 squared is 64, minus 9 squared is 81, and then I squared is just I squared. And then step number 4, we want to input -1 for all I squared values and evaluate. So we need to input -1 for I squared here, and also I squared on the denominator. So 48i plus 54, insert -1 for I squared, so times -1 over 64 minus 81, input -1 for I squared, so -81 times -1, and then evaluate that. We have 48i plus, or 54 minus 1 is -54, and then you have 64 minus 81, -81 times -1 is positive 81. If we keep simplifying that, we have 48i minus 54, and then 64 plus 81 is 145, and then right here, we need to simplify and reduce the fraction if possible. Well, 48 and 48i minus 54 over 145 doesn't simplify, so we can't reduce it anymore. So then we move to step 6, which is to split the term into two separate fractions. That way the term is in the standard form of a complex number, a plus bi. So if we split the term 48i over 145 minus 54 over 145, and then we actually want to switch these terms around to negative 54 over 145 plus, that's 145 plus 48i over 145. Then now our form is in, our answer is in the form a plus bi, and that's your answer, negative 54 over 145 plus 48i over 145. And actually, with this answer right here, the I should be to the right of the fraction. So it should be negative 54 over 145 plus 48 over 145i. 6. Perform the indicated operations. Negative 5 plus the square root of negative 16, all in parentheses, squared. Simplify your answer. Type your answer in the form a plus bi. So step 1 is going to be to evaluate the expression, and since we're solving a complex number, our goal, if possible, is to get the answer in the standard form of a complex number, which is a plus bi. And in this case, since you have a square root of a negative number, which is square root of negative 16 right here, because you have the square root of a negative number here, that's how we know that this equation, or this term, is a complex number. So step 2, we want to go ahead and multiply the expression as it shows. So multiply negative 5 plus the square root of negative 16 times itself. And then we just want to distribute the parentheses. So we have negative 5 plus square root of negative 16 times negative 5 plus square root of negative 16. And then we just have to distribute these terms. So it would be negative 5 times negative 5 times square root of negative 16. And then also we have to distribute the bottom terms. Okay, so negative 5 times the negative 5, it gives us positive 25. And then negative 5 times square root of negative 16 gives us negative 5 square root of negative 16. And then to distribute this second part, to distribute the square root of negative 16, we have square root of negative 16 times negative 5 is negative 5 square root negative 16, and then the square root of negative 16 times the square root of negative 16, we can write this as plus square root of negative 16 times negative 16, because it's just the same number by itself. Now for step 3, square root of negative 16 times negative 16 reduces to negative 16, since any number multiplied by itself under a radical is equal to itself. We need to just get rid of the radical altogether and put negative 16. So in this case, we have negative 16 times negative 16 all under a radical. And because these two numbers are by itself, we can just get rid of the radical altogether. So we end up with 25 minus 5 square root negative 16 minus 5 square root negative 16, just minus 16. Now step 4, we want to go ahead and group like terms and simplify. So 25, then negative 5 square root of negative 16 minus 5 square root of negative 16 will give us negative 10 square root negative 16, and then just minus 16. And then if we group the like terms, 25 minus 16 minus 10 square root negative 16. 25 minus 16 gives us 9 minus 10 square root negative 16. It should be 10 square root negative 16. Now going to step 5. Separate negative 10, negative 16 into two radicals. You want to get the value of square root of negative 16 to be a positive number under the radical. You want negative square root of negative 16 to just be square root of positive 16. To get this, we have to multiply 10 times negative 1 times the square root of 16. Our equation would now be 9 minus 10 square root of negative 1 times square root of 16. So really we're trying to get rid of this negative sign right here. We don't want a negative sign under the radical. So we need to try to take this and put it into two separate radicals. So we have minus 10 root minus 1 and then times the square root of 16, because square root of negative 1 times the square root of 16 is still the square root of negative 16. But now what's going to be nice is once 16 is positive, then we can simplify that, and then with a negative 1 under the other radical, then we can substitute it for I squared. But before we end up doing that, let's just go ahead and number 6, simplify square root of 16 to 4. So you have 9 minus 10 square root negative 1 square root 16 is the same as 4 times 4, which if you simplify it is just 4 itself. Make sure you have the parenthesis. And then for step 7, you need to go ahead and multiply that 4 that's left outside of the radical to the right of the radical. We need to multiply negative 10 and 4, because these are the two terms outside of the radical. So you have 9 minus 40, because negative 10 times 4 is negative 40, and then square root of negative 1. And then for step 8, it says input I squared for all negative 1 values. Square root of negative 1 becomes the square root of I squared. So right here we have a negative 1 value. We want to substitute that for I squared. So we have 9 minus 40 square root of I squared. And then our final step, step 9, is to go ahead and simplify the square root of I squared to I, and the equation becomes 9 minus 40i. So this right here, I squared, will simplify to just I, so we're left with 9 minus 40i, and that's the answer. 7. Perform the indicated operations and write the result in standard form. So just rewrite the equation, -7 minus square root of -3 squared. So we want to evaluate the expression and try to put the equation in standard form of a complex number, a plus bi. So step 2, since we have an exponent to the second power, we want to multiply -7 minus the square root of -3 by itself, and then we want to go ahead and distribute the parentheses. So -7 minus square root of -3 all times itself. Then we want to distribute each of these terms. So to start, we multiply -7 times -7 is positive 49. -7 times negative square root of -3 is positive 7 square root of -3. Then move to our second term right here. Negative square root of -3 times -7 is positive 7 square root of -3. And then square root of -3 times square root of -3 just becomes positive square root of -3 times -3. Moving on to step 3. Square root of -3 times -3 reduces to -3 since any number multiplied by itself under a radical is equal to itself. Just get rid of the radical altogether. Just put -3. So this right here will simplify. So you end up with 49 plus 7 square root of -3 plus 7 square root of -3, and then just minus 3. Now for step 4, group the terms and simplify. You have 49 plus square root of 7 plus square root of 7 square root of -3 plus 7 square root of -3 is 14 square root of -3 minus 3. And then for step 5, it says input input 1 squared for all -1 values. -1 becomes I squared. Now, this is kind of one step ahead. There's actually one more thing you need to do with this problem. And the thing is, you don't want to have a -3 under the denominator. So what you need to do is you need to actually, I'm going to consider this part as step 4. So for this, you need to have 49 plus 14. To get rid of the -3 in the denominator, you would just times it by -1 times positive 3 minus 3, because the -1 can be simplified. And then the 3 now is a positive number, so that's good. And let's even simplify. Right here we have 49 minus 3 plus 14 square root of -1 square root of 3. 49 minus 3 is 46 plus 14 square root -1 square root of 3. And then now moving to step 5, input I squared for all -1 values. Square root of -1 becomes square root of I squared. So we would essentially have 46 plus 14 square root of I squared square root of 3, and then step 6 is to simplify the square root of I squared to I. The equation becomes 46 plus 14I, the square root of 3, which puts the complex number in standard form a plus bi. So this right here, the I squared will simplify to an I, so you end up with 46 plus 14I root 3. And then your equation is in the a plus bi form, which is the standard form of a complex number. And again, that's your answer, 46 plus 14I square root 3. Perform the indicated operations. -7 minus the square root of -80 over 56. Simplify your answer. Type your answer in the form a plus bi. So the first thing we want to know is, for any positive real number b, the square root of -b is equal to I times the square root of b. Begin by using this fact to express the square root of -8 or -80 in the given expression in terms of I. And the square root of -80 is the same as the square root of -1 times 80, and -1 becomes I squared, which becomes I by itself. The equation is now -7 over negative square root of 80 over 56I. So to see that, just rewrite the equation, -70 minus square root of -80 over 56. And then again, we want to take the -80, and we know it's the same as -1 times the square root of -1 times square root of 80. So we can write it as such, because we don't want a negative number in the denominator. We can't do anything with that, so we need to split it up. So -7 minus -1, and then times the square root of 80, and all of this over 56. Next, we need to go to step 2 here. It says, well, actually, we're still on step 1. It wants us to take the -1 value, which becomes I squared. So we have -7 minus input I squared value for -1, so I squared 80 over 56. And then if we simplify the I squared, it's -7 minus I over 80, all of that over 56, which we can just write as -7 minus 80 over 56, and then put the I on the right side of the equation. So now our equation is -7 minus square root of 80 over 56I, which is what we have over here on the right. Now step 2, separate the fraction into two separate fractions. So if we did that, we'd have -70 over 56 minus square root of 80 over 56I. Now step 3, simplify the real part of the equation, -7 over 56. So we can simplify this part right here, -7 over 56, and -7 goes into itself once, 7 goes into 56 8 times. Then we'd have minus square root of 80 over 56I. and that just is 1 over 8 minus square root of 80 over 56 I. And then for step 4, it says simplify the imaginary part of the equation, negative square root of 80 over 56I. Focus on simplifying the radicand value of square root of 80, and then simplify the denominator of the imaginary part 56 and its coefficient 4. So there's a few steps here. The first thing is to focus on the value in the radicand. We want to simplify that. So 1 over 8 minus. Now we want to simplify square root of 80, so we need to find multiples of that. I can think 5 is a multiple of 80, and 5 goes into 80 16 times, so 16 times 5 over 56I, and then have 1 over 8 minus the 16 is the same as 4 times 4 times 5 over 56I, and that simplifies to 1 over 8 minus 4, because we move this 4 to the left of the radicand, 4 square root of 5 over 56I. And right here it says simplify the denominator of the imaginary part 56 and its coefficient 4. So we can simplify 56 and the 4. 4 goes into itself once, and then 4 goes into 56 14 times. And that leaves our equation at 1 over 8 minus 1 square root of 5 over 14I. And then step 5, negative 1 over square root, or negative 1 square root of 5 over 14I can be written as negative 5 as negative square root of 5 over 14I. The I value is implied. So in this case, this I value right here is implied, so we can simply rewrite the equation as 1 over 8 square root of 5 over 14I. So it's 1/8 minus square root of 5 over 14I. That's the answer. 9. Perform the indicated operations and write the result in standard form. 9 square root of negative 12 in parentheses times negative 7 square root of negative 13 in parentheses. Type an exact answer using radicals as needed. Type your answer in the form a plus bi. So to start, step 1, we want to get rid of the negative number in both radicands. So in this case, you have negative 12 in this radicand and negative 13 over here. So I'm going to get rid of the negative number by using the principal square root of a negative number. And this principle states that square root of negative b is just I square root of b. Using this makes 9 square root of negative 12, 9I square root of 12, and it makes negative 7 square root of negative 13, negative 7I square root 13. So let's see how this is done. We can rewrite the problem down here. So 9 square root of negative 12 times negative 7 square root of negative 13. And again, we want to get rid of this negative numbers under the radicals. So to get rid of these negative numbers, we have to again use this principle of square roots. So 9 square root of negative 1 times square root of 12. Negative 1, square root of negative 1 times square root of 12 is the square root of negative 12. And then multiply that by negative 7 square root of negative 1 square root of 13. Because again, this right here is using the principal square root of a negative number, which states that negative under the radicand can be split up into two separate radicals multiplied by each other, and then you end up substituting the negative 1 for I squared. So actually that's what we have to do now. We have to take each instance of negative 1 and input I squared for it. So we end up with 9 square root of I squared times 12 times negative 7 square root of I squared times 13. And then if we simplify that, it ends up being 9I square root of 12, and then negative 7I, because I squared simplifies to I, and then square root of 13. And that's what we had here. 9I 12, negative 7I square root of 13. So now moving to step 2, we want to group together the like terms. In this example, you can group both imaginary terms, 9I and negative 7I, which is what we have right here. We can group those together, and you can also group together both radical terms, square root of negative 12. It actually should be the square root of 12 and the square root of 13, since we got rid of the negatives. This is possible since a times b in parentheses times c times d equals ac in parentheses times bd. So using this principle of AB times CD equals AC times BD, we can kind of make each of these A, B, C, D. And it says AB times CD equals AC times BD. So in this case, our A is the 9I, which is one imaginary term, and we can multiply it by our C term, which in this case is negative 7I, which is also an imaginary term we're grouping together. And then you have your B term, which is square root of 12, and we can group that and multiply that with our D term, which is the square root of 13. Now step 3, we need to simplify by multiplying both groups of like terms. Multiply the imaginary numbers 9I times negative 7I, then multiply square root of 12 by square root of 13. So 9I times negative 7I is negative 63 I squared, and then square root of 12 times square root of 13 is square root, I think it's 156. We can actually check that right here. So 13 times 12, 2 times 3 is 6, 2 times 1 is 2, 0, 3, 1, 156. Alright, so that's right, 156. And then now moving to step 4, input negative 1 for all I squared values and multiply. So right here we have negative 63 I squared, so we can input negative 1 for the I squared, so negative 63 times negative 1, and then times root 156. Negative 63 times negative 1 is just positive 63. Make sure to keep the parentheses. Times square root of 156. Step 5. Simplify the radical square root of 156, which becomes 2 times square root of 39. So, to simplify 63 times, gotta make sure we keep the parentheses. So 63 times the square root of 156. Well, 156 will simplify. 156 goes into 2, or 2 goes into 156. Half of 156 is 80, 78. 4 will also go into 156, so we would have 63, and then it'd be 4 times half of 78 is 39, so 4 times 39, and then you'd have 63 square root of 2 times 39, and you'd have 63, and then 2 would just move to the left, so 2 times the square root of 39, and that's what we have right here, 2 square root of 39. Now for step 6, it says multiply both terms. So multiply 3 by the coefficient of the radical term, which is 2. It should actually say multiply 63 by the coefficient of the radical term, which is 2. So we have to multiply 63 times 2, because 2 is to the left of the radical. It's outside of the radical. So we have 63 times 2, which is 126 square root of 39. And that's your answer. Perform the indicated operations. 3 minus 5i in parentheses times 1 minus I in parentheses minus 4 minus I in parentheses times 4 plus I in parentheses. So for step 1, we want to go ahead and distribute the two different sets of complex numbers in parentheses. So we can just rewrite everything. So you have 3 minus 5i in parentheses times 1 minus I in parentheses minus 4 minus I in parentheses plus, or times 4 plus I in parentheses. So we want to distribute the different sets of parentheses. So we have to distribute each of the terms. Now, and also on the right side, 4 minus I times 4 plus I, we should notice that this is a difference of squares. We know that because the difference of squares is just a minus b times a plus b, which will give us an answer of a squared minus b squared. Okay, so let's start with distributing the 3. 3 times 1 is 3. 3 times negative I is negative 3i. Negative 5i times 1 is negative 5i. And then negative 5i times negative I is positive 5i squared. And let's put all of that in parentheses. And then minus, we already said here that this is a difference of squares. The 4 would represent the a value, and then the I would represent the b value. So it would just be a squared, which would be 4 squared, minus b squared, which would just be I squared. Okay, now for step 2, it says to make special note to distribute the negative sign with all 4 terms in the parentheses. Now, there was 4 terms in the parentheses because when I did this right here, I did it the long way. I did 4 minus I times 4 plus I. and I had actually distributed each term, which gave me 4 times 4 is 16. 4 times I is plus 4i, minus I times 4 is minus 4i, and then minus I squared times I is just negative I squared. But I actually saved time because by using this method right here, it gets rid of these two terms in the middle and just leaves you with your a squared value and your b squared value. So we need to make sure we distribute the negative sign with 4 squared and the negative sign with negative I squared. So to do that, we have 3 minus 3i minus 5i plus 5i squared in parentheses, and negative times 4 squared is just minus 4 squared, and then negative times negative I squared is just plus I squared. Now in step 3, combine like terms. We can actually lift up these parentheses. We can get rid of these parentheses. So we have 3 minus 3i minus 5i plus 5i squared minus 4 squared plus I squared. So what are our like terms? Well, to begin with, we can simplify this 4 squared. So we have 3 minus 3i minus 5i plus 5i squared. 4 squared is just 16, so minus 16 plus I squared. And for our like terms, we have negative 16, so 3 minus a negative 16. No, that's not right. It would be 3 minus 16, then it would be minus 3i minus 5i plus 5i squared plus I squared. And 3 minus 16 is negative 13. It's negative 13, and then negative 3i minus 5i is negative 8i, and then plus 5i squared plus I squared. And actually 5i squared plus I squared is 6i squared, so minus 13 minus 8i plus 6i squared. Now for step 4, we want to input negative 1 for all I squared values. So we have negative 13 minus 8i plus 6. Input that negative 1 for the I squared value, so 6 times negative 1. So you end up with negative 13 minus 8i. 6 times negative 1 is minus 6. And that's kind of what we did right here. By multiplying the two, we were simplifying. And then for the last step, just group like terms and simplify. So negative 13 minus 6 would be grouping the like terms, these like terms right here. And then minus 8i, so you have minus 19 minus 8i, and this right here is in the standard form of a complex number, which is 8 plus bi. So your answer is negative 19 minus 8i. 11. Solve the equation by factoring. X squared equals 6x plus 27. Step 1. To solve, you must put this quadratic equation in standard form, ax squared plus bx plus c equals 0. This means you need to get 0 on the right side of the equation. So you got to get 0 by itself on the right side of the equation, and to do this, subtract 6x and 27 from both sides. So rewrite the equation. X squared equals 6x plus 27. Again, our goal is to get 0 on one side, so we start by subtracting -6 from both sides. So you have x squared minus 6x equals 27. Again, get 0 on both sides, so subtract 27 from both sides. You have x squared minus 6x minus 27 equals 0. And then step 2. Once the equation is in standard form, then factor the quadratic trinomial. Find two numbers when multiplied equal the third term, but when added together equal the middle term. So x squared minus 6x minus 27 equals 0 is in the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. So we want to factor x squared minus 6x minus 27. So we can start using the FOIL method, and we need to figure out what two numbers when multiplied equal -27, but when added equal our middle term -6. So right off my head I can think of -9 times +3 equals -27, and -9 plus 3 equals -6, which is our middle term. So that's our factorization. And then step 3, once factored, use the principle of zero products to find the possible solutions of each factorization. Do this by setting each factor equal to 0. So use the principle of zero products to put each factorization, so x plus 3 equals 0, and then you want to set the other factorization of x minus 9 equal to 0 as well, and then just solve for x. So -3, x equals -3, plus 9, x equals 9. And step 4, we want to go ahead and check both solutions, -3 and 9, by plugging each value as x in the original equation. So we want to take our original equation, x squared equals 6x plus 27, and we want to plug in -3 and 9 to make sure that doing that yields true statements, which will let us know that these solutions are indeed solutions. So let's start with -3, put -3 in for x, so -3 squared equals 6 times -3, because -3 is for substituting for x, plus 27. -3 squared is +9 equals 6 times -3 is -18 plus 27. 9 equals -18 plus 27 is +9. 9 equals 9. This is true statement. So we know that -3 is one of our solutions, and now we need to plug in the 9 value. So plug in the 9 value for x, so 9 squared, make sure you keep the parentheses, 9 squared equals 6, substitute 9 for x, plus 27. 9 squared is 81, equals 6 times 9 is 54, plus 27. 81 equals 54 plus 27 is 81. 81 equals 81. So this is also a true statement. It's also a true statement. So +9 is an answer. And then step 5, put the solutions in set builder notation inside curly brackets. So bust out our braces, or as we call them, curly brackets. Put in our first solution, -3, comma, our second solution, +9. Close it with the curly brackets, and -3, 9 is your answer. 12. Solve the equation by factoring. 9x squared plus 21x minus 8 equals 0. 1. The equation is already in the standard form of a quadratic equation. So in this case, 9x squared plus 21x minus 8 equals 0 is already in ax squared plus bx plus c equals 0 form. It's already in the standard form. So we can go to step 2. Step 2 is kind of long. We'll just talk about each part. So once the equation is in standard form, then factor the quadratic trinomial. So we need to factor 9x squared plus 21x minus 8 equals 0. Now before we start, we have to consider a few things. Since the coefficient has an exponent on the ax squared term of the trinomial, which is 9, so we have this coefficient on the ax squared term, which is 9x squared. Since the coefficient has an exponent on the ax squared term of the trinomial, which is 9, note that this is not a prime number. If the coefficient of the ax squared term is a prime number, then the factorization will begin with that prime coefficient value. In this case, 9x squared is not a prime number, so this does not apply. But if 7x squared was the coefficient value, then we would factor this trinomial using 7x times x. If you have a coefficient value of ax squared that is not 1, which 9 isn't 1, 9 is 9, you need to first determine the possible factorizations of the first term. In this case, ax squared can only be factored as 9x times x, or 3x in parentheses times x in parentheses. So 9x can only be factored as 9x times x, or 3x times 3x. That's the factorization of the first term, 9x squared. It says then you need to find the factorizations of the last term. In this case, -8 factors only as -8 times 1, or -4 in parentheses times 2 in parentheses. And it says then you need to combine the 4 factorizations into one that will give you the value of all 3 terms of the trinomial. So the factorization of the first term is 9x and then x in parentheses, 3x, x in parentheses. But you also need to find what 2 numbers when multiplied will equal your last term, -8. And the only terms that will equal -8 are -8 times a +1, or you could have -4 times a +2. Now, if we multiply 1 times -8, yes, we do get -8, but we also need to get the middle term value of 21x. And when we multiply 9x times -8, we get -72x plus 1x, which is -71x. And that is not 21x. So that's not a solution. Next, we have negative 4 times 2, which is negative 8, but 9x times negative 4 is negative 36, plus 2x is negative 34, which is not 21x, our middle term. So these two don't work. And then we can use the same factorization of negative 8 with our 3x times 3x. So we have minus 8 and then plus 1. And we can also do 3x 3x plus 2, 3x minus 4. So 1 times negative 8 is negative 8, our last term. And then 3x times negative 8x is negative 24x. Okay, and then negative 24x plus 1 times 3x plus 3x gives us negative 21x. But negative 21x isn't our middle term because it's 21x is positive. So let's try this other one. 3x, let me see, negative 4 times 2 is our last term, negative 8. And then 3x times negative 4 is negative 12. But then if you add that, if you add negative 12x to 2 times 3x times 6x, so negative 12x plus 6x is negative 6x, and that's not right. But actually the closest one we got was this one right here, which gave us negative 21x. So if you see that kind of situation, what you can do is, in this case, we had minus 8 on the right side and positive 1 on the left side. We can just reverse those. So instead of positive 1, we can have minus 1, and 3x instead of minus 8, it can be plus 8. Now if we multiply negative 1 times 8, we get negative 8, our last term. And then you have 3x times 8x, which is 24x. And then negative 1 times 3x is negative 3x. And 24x plus negative 3x is just 21x, which is our middle term. So this right here is our factorization. Now for step 3, once factored, use the principle of zero products to find the possible solutions of each factorization. Do this by setting each factor equal to 0. So we can take each factorization, 3x minus 1, set it equal to 0, and then 3x plus 8, and also set that to 0. And now we just need to solve for x, so add 1 on both sides, 3x equals 1, divide 3 on both sides to get x by itself, x equals 1/3. And then for this one, 3x plus 8 equals 0. Subtract 8 from both sides. 3x equals negative 8. And then divide 3 from both sides. You have x equals negative 8 over 3. So these are our solutions. But before we know that for sure, we need to go to step 4. And step 4 wants us to go ahead and check both solutions, negative 8 and 1/3, by plugging each value as x in the original equation. And our original equation was 9x squared. We had 9x squared plus 21x minus 8 equals 0. So we want to start off by plugging in 1/3 for each of our x values into the original equation. So you have 9 times 1/3 squared plus 21 times 1/3 minus 8 equals 0. And if we simplify that, 1/3 squared using PEMDAS, we got to do the squared thing first. So 1/3 squared is 1/3 times 1/3, which is 1/9, plus 21 times 1/3 minus 8 equals 0. Now if we multiply 9 times 1/9, we get 9/9. And then if we multiply 21 times 3, it's just 21/3. 21 times 1 is 1. 1 times 3 is 3. Minus 8 equals 0. If we simplify this, 9/9, 9 goes into itself once, so it's just 1. 3 goes into itself once. 3 goes into 21 7 times, so 1 plus 7 minus 8 equals 0. 1 plus 7 is 8. Minus 8 equals 0. 0 equals 0, which is true. It's a true statement. So 1/3 up here is the solution. Now we can go ahead and plug in our negative 1/8 into our original equation. So it will be 9 times negative 8/3 squared plus 21 times negative 8/3 minus 8 equals 0. And negative 8/3 squared is just negative 8/3 times negative 8/3, which we can go ahead and simplify. Negative 8/3 and negative 8/3 is 64/9 plus 21 times negative 8/3 minus 8 equals 0. Now, if we multiply 9 times 64/9, it's pretty much the same thing as 9/1. And we can actually simplify these fractions. 9 goes into itself once, 9 goes into this 9 once, and that gives us 64 times 1 is 64/1, which is the same as 64. And then plus, we have 21/1 times negative 8/3 minus 8 equals 0. 3 goes into itself once, 3 goes into 21 7 times. And then you have 7 times negative 56, just minus 56/1, which is the same as minus 56. And then you have minus 8 here equals 0. 64 minus 56. 64 minus 56 is just 8. Minus 8 equals 0. And then 0 equals 0. And this is also a true statement. So we know that in this case, negative 8/3 is also a solution. And then for step 5, we want to put the solution in set builder notation inside curly brackets. So get the curly brackets, you got 1/3, and then your other solution is negative 8/3. And maybe just as a matter of habit, we could put the negative value on the left, so negative 8/3, comma, 1/3, and that's your answer. (13) Use factoring to solve the quadratic equation. Check by substitution, or by using a graphing utility and identifying x-intercepts. 5x squared equals 39x plus 8. Use commas to separate answers as needed. Type repeated roots only once. So step 1 is to put the equation into standard form ax squared plus bx plus c equals 0. Do this by subtracting 39x and 8 on both sides. So rewrite our original equation. 5x squared equals 39x plus 8. So let's subtract 39x from both sides. 39x minus 39x. So you have 5x squared minus 39x equals 8. To get 0 on one side, subtract 8 from both sides. So you have 5x squared minus 39x minus 8 equals 0. And now our equation is in standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. Then step 2, we want to go ahead and factor the equation in standard form. Since the ax squared coefficient is prime, in this case 5, the number 5 is prime, the factorization will be set up as 5x times x. To find the middle term, just think 5 multiplied by what factor of negative 8 will get you the value of the middle term, negative 39x. So to begin with, because our ax squared term right here, 5x squared, because the coefficient 5 of that ax squared term is a prime number, then our factorization will be that prime number 5x just times x. Because 5x can only be times 1, x is basically the same as 1x because 5 is a prime number. It's not multiple by, you can't multiply it by any other number. So, and then it says to find the middle term, just think 5 multiplied by what factor of negative 8 will get you the value of the middle term, negative 39x. Well, there's a few different possibilities. There's actually 4 possibilities. You could have what times what will give you negative 8. You could have negative 4, positive 2. You could have positive 4, negative 2. You could have negative 8, positive 1. You could have positive 8, negative 1. So let's try these. 2 times negative 4 is negative 8, but 5x times negative 4 is negative 20, and then negative 20 plus 2x is negative 18x, which isn't equal to negative 39x, our middle term. So this one won't work. Now, what if we multiply 5x by 4 is 20x, minus 2x is positive 18x. Our middle term is negative 39x. So this one won't work. Now, 1 times negative 8 is negative 8, which is our third term. And if we multiply 5x times negative 8, we get negative 40x. And then 1 times x is just x. So negative 40x plus positive x is negative 39x, which is our middle term. So this will be the factorization. Because even if you look at this last possible factorization, 5x times 8x, or times 8, is 40x, and minus 1x, minus 1 times x is minus 1x, so 40x minus x is positive 39x, and we had negative 39x, so that's not a possible factorization. And again, with intuition, you can kind of figure out what will more likely be the factorization, but it's good to go through and see all the possibilities just to get your mind working like that. So, step 3, use the principle of zero products to set both factorizations 5x plus 1 and x minus 8 equal to 0 and solve for x. So we had the factorization of 5x plus 1 and x minus 8. We'll set each of those equal to 0. And then x plus 8 equals 0. And we'll just solve for x. So minus 1, 5x equals 0. Or 5x equals negative 1. Divide 5 on both sides to get x by itself. X equals negative 1/5. And then subtract 8 from both sides here. X equals negative 8. Well, actually, I wrote this down wrong. This right here should be we had a subtraction sign. So this should be x minus 8 equals 0. So what we'll do is we should be adding 8 to both sides. So x equals positive 8. Now step 4, we want to check the solutions by plugging them in as x values into the original equation. 5x squared equals 39x plus 8. Or graph y equals 5x squared minus 39x minus 8. And verify that it has x-intercepts at x equals negative 5 and x equals 8. So we'll just go ahead and use the substitution method, and we'll just plug in the x values into the original equation. So our original equation, let's just write that down right here again. It's just 5x squared equals 39x plus 8. And we got a possible solution of negative 1/5. So we'll plug that in. 5 times negative 1/5 squared equals 39 times negative 1/5 plus 8. Yeah, this is a 5. So 5, alright, negative 1/5 squared is the same as 5 times negative 1/5 times negative 1/5 equals 39 times negative 1/5 plus 38. So negative 1/5 times negative 1/5 would be 5 times 1 positive 1 over 25 equals 39 times negative 1/5 plus 8. And then 5 times a 1/25 is just the same as 5 over 25 equals 39 times negative 1/5 plus 8. And 5 over 25, 5 goes into itself once, 25 goes into itself 5 times. So we have 1/5 equals 39 over negative 1/5 plus 8. And then 39, let me see, 1/5 equals 39 over 1, multiply it by negative 1/5 plus 8. 39 times negative 1 is just negative 39 over 5 plus 8. To add these two fractions, we need the LCD. So the lowest common denominator for both would be 5. So you can multiply numerator and denominator by 5. So you have 1/5 equals negative 39 over 5 plus 40 over 5. And 1/5, negative 39 over 5 plus 40 over 5 is 1/5. So 1/5 equals 1/5. So this is true statement. And because it's a true statement, then we know that negative 1/5 is one of our solutions. And now we have to try our other solution, x equals 8. So let's go ahead and plug that into our original equation. So we have 5x squared equals 39x plus 8. We'll plug the 8 into this equation, so 5 times 8 squared equals 39 times 8 plus 39 times 8 in parentheses plus 8. So we'll do PEMDAS. 8 squared is 64, so 5 times 64 equals 39 times 8 plus 8. 5 times 64, let's see, 64 times 5, 0, 2, 6 times 5, 300, 320. So 320 equals 39 times 8 plus 8. And then 39 times 8 is 2, carry the 7, 8 times 3, 24, plus 7 is 21. So 320 equals, no, this should be 8 times 4 is 24, plus 7 is 31, not 21. So it should be 312. So 320 equals 312 plus 8. 320 equals 312 plus 8 is just 320. 320 equals 320. And that's true. And because that's true, then we know that our solution right here, x equals 8, is indeed a solution. And then for step 5, we just want to go ahead and put both, should say both solutions in set builder notation. So you start with your negative 1/5 in the curly brackets and 8. Close it with a curly bracket, and negative 1/5 and 8 is your solution. 14. Solve the following quadratic equation by the square root property. 2x squared plus 3 equals 203. Simplify your answer. Type an exact answer using radicals as needed. Use integers or fractions for any numbers in the expression. Use a comma to separate answers as needed. So to begin with, we want to get the squared term, x by itself, and then subtract 3 from both sides and divide 2 from both sides to get the squared term x by itself. So rewrite our original equation, 2x squared plus 3 equals 203. Now we want to get the squared term x squared by itself. So we subtract 3 from both sides. That gives us 2x squared equals 203 minus 3 is 200. And then to get x squared by itself, we want to divide 2 by both sides. We end up with x squared equals 2 over 200. 2 goes into itself once, 2 goes into 100 times. So x squared equals 100. Now step 2. Now that x is by itself, use the square root property to square both sides of the equation, which gets rid of the exponent of 2 on x. So we want to get rid of the exponent 2. We want to get x by itself. So we have x squared equals 100, and we just use the square root property on both sides. That gives us pretty much just x times x equals 10 times 10. And when you have this by itself, the x moves to the left side, 10 moves to the left side, so you end up with x equals 10. And actually we also did step 3, which is simplify the radicand square root of 100, which just becomes plus or minus 10. That's what we did right here. We took the radicand square root of 100 and we just simplified it into plus or minus 10. So now we have, and actually it's important to note that it is x equals plus or minus 10. So we need to now go to step 4, which is to check your solutions by plugging them into the x value of the original equation 2x squared plus 3 equals 203. So let's start with positive 10. Our original equation was 2x squared plus 3 equals 203. We'll plug in a positive 10. Positive 10 squared plus 3 equals 203. PEMDAS will do 10 squared, which is 100. 2 times 100 plus 2 times 100 plus 3 equals 203. 2 times 100 is 200 plus 3 equals 203. 200 plus 3 is 203 equals 203. This statement's true. Therefore, positive 10 is an answer. Now let's plug in negative 10. 2 times negative 10 squared plus 3 equals 203. PEMDAS, negative 10 squared is 100. 2 times 100 times 100 plus 3 equals 203. 2 times 100 is 200 plus 3 equals 203. 200 plus 3 is 203 equals 203. This is also a true statement. Therefore, negative 10 is a solution. And now for step 5, we want to put the answers in set builder notation. So we have our braces or curly brackets, negative 10, and then comma, positive 10, close the set builder notation, and negative 10 and 10 is your answer. 15. Solve the equation by the square root property. 2 times x plus 9 in parentheses squared equals 90. Type an exact answer using radicals as needed. Use a comma to separate answers as needed. Simplify your answer. So step 1, we want to get the squared amount, which is x plus 9 in parentheses squared by itself. To do this, divide both sides by 2. So we can rewrite our original equation. 2 x plus 9 squared equals 90. And we want to divide both sides by 2. That way we can get this x plus 9 squared by itself. That leaves us with 2 goes into itself once, 2 goes into 2 once. So that leaves us with x plus 9 squared. 2 goes into itself once, 2 goes into 90 45 times. So x plus 9 squared equals 45. And now for step 2, want to use the square root property to reduce the square root of x plus 9 squared to x plus 9. This gets rid of the exponent value of 2. As a result, on the right side you have the square root of 45. So if we, using the square root property, if we go ahead and have x plus 9 squared equals 45, to get rid of this exponent value, we can square both sides using the square root property, and squaring both sides gives us just x plus 9 equals square root of 45. Step 3, factor square root of 45 into square root of 9 times 5 and into square root of 3 times 3 times 5, which becomes plus or minus 3 square root of 5. So the square root of 45 right here will simplify. It can factor to 9 times 5, and then 9 times 5, 9 can factor into 3 times 3, which equals 9, times 5, which equals 45. When simplified, will equal x plus 9 equals plus or minus 3 square root of 5. Now for step 4, we want to subtract negative 9 from both sides. So we have x plus 9 equals plus or minus 3 square root of 5. Again, we're trying to get x by itself, so subtract 9 from both sides. X equals negative 9 plus or minus 3 square root of 5. And for step 5, we want to write the answers in set builder notation separated by a comma, making sure to include the positive 3 square root of 5 and the negative 3 square root of 5 parts of the radical term. So we have to include both the negative and positive value of our solutions, and we need to put that into set builder notation. So we end up with negative 9 plus 3 square root of 5, and then negative 9 minus 3 square root of 5. And that right there is our answer. 16. Solve the quadratic equation using the square root property. X minus 4 in parentheses squared equals negative 5. Simplify your answer. Type an exact answer using radicals as needed. Express complex numbers in terms of I. Use a comma to separate answers as needed. So for step 1, we want to use the square root property to get rid of the squared exponent value on the term x minus 4 squared, which after you use the square root property just becomes x minus 4. So let's take our initial equation, x minus 4 squared equals negative 5, and we want to use the square root property to help us get rid of this exponent value on this term right here, x minus 4. So we square the left side of the equation. Because we do the left side, we also have to square the right side of the equation. This gets rid of the exponent value and leaves us with x minus 4 equals the square root of negative 5. Now for step 2, it says for the square root of negative 5, remember that a negative number as the radicand, so having a negative number under the radical, such as what we have here, in square root of negative 5, is the same as the square root of negative 1 times 5. Then we can input I squared for all negative 1 values, in which case square root of negative 5 becomes the square root of negative 5 I squared, which simplifies to plus or minus I square root of 5. So overall, we just don't want a negative number as the radicand. So we don't want a negative number under the radical. So to get rid of that, just as we mentioned, the square root of negative 5 is the same as square root of 1 times square root of 5. And then we want to input I squared for all our negative 1 values. So this negative 1 becomes I squared times square root of 5. And then I squared simplified just becomes I square root of 5. And actually, it's actually equals plus or minus I square root of 5. And for step 3, we want to simplify and get x by itself. To do this, we need to add 4 to both sides. So we're trying to get x by itself, so we want to add 4 to both sides of the equation, which gives us x equals plus or minus, or gives us x equals 4 plus or minus I square root of 5. Now, for step 4, with your answer, make sure to include the negative and positive answers, since a square consists of a negative and a positive answer. you end up with x equals 4 plus I square root of 5, or x equals 4 minus I square root of 5. So pretty much just this right here, 4 plus or minus I square root of 5. I know what another way to write that is to just write each solution separately. So you'd have x equals 4 plus I square root of 5, or x equals 4 minus I square root of 5. And then the last step, step 5, we want to go ahead and put the solutions in set builder notation. So get our curly brackets. We have 4 plus I square root of 5, comma, 4 minus I square root of 5. Close it with curly brackets, and that's your answer. 17. Solve the quadratic equation by the square root property. 4x plus 7 in parentheses squared equals 64. Simplify your answers. Type exact answers using radicals as needed. Use a comma to separate answers as needed. So step 1, we want to go ahead and use the square root property to get rid of the squared exponent value on the term 4x plus 7 squared, which after using the square root property just becomes 4x plus 7. So we have our initial equation, which we'll write down again, 4x plus 7 squared equals 64. And if we apply the square root property, then we're going to square both sides, put the radical over both sides, and then we end up with just 4x plus 7 by itself equals the square root of 64. Now for step 2, applying the square root property essentially gives you two separate equations. You end up with 4x plus 7 equals the square root of 64, and 4x plus 7 equals negative square root of 64. This occurs since the square root represents both a negative and a positive number, since in this example 8 squared and negative 8 squared both represent the square root of 64. So since 8 squared is 64, negative 8 squared is 64, we need two equations. So we need 4x plus 7 equals the square root of 64, and then 4x plus 7 equals negative square root of 64. So for step 3, we need to solve each equation. 4x plus 7 equals square root of 64, and 4x plus 7 equals the negative square root of 64 separately. We need to solve for x in each equation. So we need to solve each one of these equations separately, and for each one we need to solve for x. Now for step 4, on the left side we need to subtract 7 on both sides and divide by 4 on both sides to get x by itself. So to get x by itself, we need to subtract 7 from both sides. But actually, before we do that, part of step 3, we should go ahead and just simplify, get the term out of the radical. So square root of 64 is the same as 8 times 8. So 4x plus 7 just equals 8. And then same thing here, 4x plus 7 equals square root of 8 times 8. So 4x plus 7 equals negative 8. Now going with what they were saying in step 4, we want to subtract 7 on both sides and then divide 4 on both sides to get x by itself. So subtract 7 from both sides, we end up with 4x equals 1. Divide both sides by 4. We end up with x equals 1/4. And then on the right side, same thing, subtract both sides by 7. So you have 4x plus 7 equals negative 15. And then divide both sides by 4. And you end up with x equals negative 15 over 4. Now, for step 5, it says on the right side of the equation, subtract 7 from both sides and then divide 4 on both sides to get x by itself. Well, I already did that. I did that right here. I subtracted 7 on both sides and then divided 4 on both sides, and I got x by itself to be negative 15 over 4. And now it says 6, put both solutions in set builder notation. So both solutions should be 1/4, and then let's put the negative value first. I got negative 15 over 4, and then 1 over 4. But let's make sure these are actual solutions. So step 7, check each solution by plugging them in as the x value of the original equation, which is 4x plus 7 squared equals 64. So let's do that. 4x plus 7 squared equals 64. Let's plug in our 1/4 value. So 4, and then you have 1/4 times 1/4, because that's the x value right here, plus 7 squared equals 64. That'd be 4 over 4, because 4 times 1 is 4, and this is the same as 4 over 1. 4 over 4 plus 7 squared equals 64. 4 over 4 is the same as 1 plus 7 squared equals 64. 1 plus 7 is 8 squared. It's just 8 squared equals 64. 8 squared is 64 equals 64. That's true, so 1/4 is the solution. Now let's plug in negative 15 over 4 for our x value. So we have 4 times negative 15 over 4 plus 7 squared equals 64. 4 times negative 15, because this is the same as 4 over 1. 4 times negative 15 is negative 60 over 4 plus 7 squared equals 64. 4 over negative 60, 4 goes into itself once, 4 goes into negative 60 15 times. So that's just the same as negative 15 plus 7 squared equals 64. Negative 15 plus 7 is negative 8 squared equals 64. Negative 8 squared is 64 equals 64. So this is also a true statement. Both of them are. And this one, because it's true, that means negative 15 over 4 is the solution. So your solutions are negative 15 over 4 and 1 over 4. Or negative 15/4 and 1/4. 18. Solve the equation using the quadratic formula. X squared plus 11x plus 3 equals 0. Type an exact answer using radicals as needed. Use a comma to separate answers as needed. So step 1, we want to use the quadratic formula, and we want to plug in the a, b, and c values accordingly. So our quadratic formula is negative b plus square root of b squared minus 4ac over 2a. So in this case, 1 is our a value, 11 is our b value, and 3 is your c value. So if we write the equation again, x squared plus 11x plus 3 equals 0, we know that the quadratic formula is negative b plus or minus b squared minus 4ac all over 2a, and then our a value is going to be the x, our b value is going to be 11. Actually, a value is not going to be x, it's going to be the hidden coefficient 1, and then 3 is going to be our c value. So we just have to plug that into the quadratic formula right here. So we have negative b, so b is 11, so negative 11 plus or minus the square root of b squared. 11 is b squared minus 4. Our a value is 1, so put that in parentheses, and then our c value is 3, so put that in parentheses as well, and all of that is going to be over 2 times a, and a is 1, so 2 times 1. Now step 2, we want to evaluate the values you input it into the quadratic formula. So we want to evaluate those. So you have negative 11 plus or minus 11 squared is 121, minus 4 times 1 is just negative 4, and then times 3 over 2. Then you have negative 11 plus or minus 121, and then negative 4 times 3 is negative 12 all over 2. Now for step 3, we're supposed to simplify as much as possible. So negative 11 plus or minus 121 minus 12 is 109, and that's all over 2. But at this point, 109 I think is a prime number, and it's not divisible by any other factors, so the radicand, the number under the radical, can't simplify. 2 is an even number, and negative 11 is an odd number, so we can't simplify that either. So step 4 now wants us to make sure to include the positive and negative solution of this radical. So the positive solution of this would be negative 11 plus 109, all of that over 2, or you have the negative solution, which is negative 11 minus the square root of 109, and all of that divided by 2. So for step 5, it says to put the answers in set builder notation. You just need your braces, your curly brackets, and then you have negative 11 plus the square root of 109 over 2, comma, you have negative 11 minus square root of 109, all of that over 2, and then that right there is your answer. As far as step 6 is concerned, it's just saying that we could use a calculator to find a decimal approximation for each solution. Like if we needed to know specifically what is each of these solutions, what is the approximate value of each solution, we could plug these into the calculator and it would give us some sort of number. But in this case, this is not necessary, since this situation, the problem is not a direct application. So just leave the irrational solution and radical form as exact answers, which is what we have right here. Solve the equation using the quadratic formula. 3x squared equals 4x plus 3. Type an exact answer. Using radicals is needed. Use a comma to separate answers is needed. So step 1, in order to solve the equation using the quadratic formula, first you need to put the equation into standard form, which is ax squared plus bx plus c equals 0. So to do this, we want to subtract 4x from both sides, then subtract 3 from both sides. So let's write our original equation. 3x squared equals 4x plus 3. Our goal is to get 0 on one side. So to do that, subtract 4x from both sides. We have 3x squared minus 4x plus 3 equals 0. Now, actually it's equals 3x squared minus 4x equals 3. Now we subtract 3 from both sides, and you end up with 3x squared minus 4x minus 3 equals 0. And now our equation is in standard form. Ax squared plus bx plus c equals 0. So step 2, we want to input a, which is 3, b, which is negative 4, and c, which is negative 3. Input these values into the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac divided by 2a. Now, you need to be careful when inputting the negative b value of negative 4, because it's minus negative 4. So don't forget, since this is a double negative, then the result is positive. So we have to input this into the quadratic formula, and the quadratic formula is minus b plus or minus b squared minus 4ac, and all of that is over 2a. So our a value is 3, our b value is negative 4, and our c value is negative 3. So input the b value, it's minus negative 4, and then plus or minus b is negative 4, so negative 4 squared, and then minus 4, a is 3, 4 times 3, 4 times 3, and then our c, actually let me make a little room here. Our 4 is c, and c is negative 3, so negative 3 right here, and that's all over 2 times a, which is 3. Now step 3 is to evaluate the quadratic formula. So if we try to evaluate this, minus and negative 4 is just positive 4, plus or minus negative 4 squared is 16, minus 4 times 3 is 12, so minus 12, and then times negative 3, and then we have 2 times 3, which is 6, and if we keep evaluating that, we have 4 plus or minus negative 12 times negative 3, so you'd have 16, and then plus 36, because 12 times 3 is 36, plus 36, and then that's all over 6, so 4 plus or minus 16 plus 36 is 52, and all of that's over 6. And if we simplify 52 divided by 2 is, let me see, 26. 52 divided by 4 is 13. So 4 plus or minus it was 26 to 13 times 4, so 4 times 13 all over 6, and then you have 4 plus or minus 4 is just the same as 2 times 13 all over 6, which is the same as 4 plus or minus 2 square root of 13 over 6. And then this will simplify. 2 goes into itself once, 2 goes into 4 twice, 2 goes into 6 3 times. So you end up with 2 plus or minus square root of 13. We don't need to include the 1, that's a given, all over 3. And then for step 4, we want to make sure to include the positive and negative solution. Negative should be solutions of this radical. So we have 2 plus square root of 13 over 3, or 2 minus the square root of 13 over 3. And we just want to go ahead, as it says in step 5, and put these answers in set builder notation. So put in your curly brackets. You'd have 2 plus square root of 13 all over 3, and then you'd have 2 minus square root of 13 all over 3, and that's your answer. Solve the equation by the method of your choice. 1 over x plus 1 over x plus 2 equals 1/2. Type an exact answer using radicals as needed. Use a comma to separate answers as needed. So to start with, what is our goal for this equation? Well, step 1, our goal is to get the equation into standard form, ax squared plus bx plus c equals 0, and solve using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we need to get this beginning part into standard form and then solve with the quadratic formula. So let's rewrite the equation. 1x plus 1 over x plus 2 equals 1/2. Now for step 2, we want to focus on the two terms on the left side of the equation, which is 1 over x plus 1 over x plus 2. We want to ignore the term 1/2 on the right side of the equation for now. Find the LCD of 1 over x plus 1 over x plus 2. The LCD is x times x plus 2. Multiply 1 over x by x plus 2 over x plus 2, and multiply 1 over x plus 2 by x over x. So again, we want to focus on the left side of the equation. We want to focus on this side. For now, we're going to ignore the right side of the equation. So we want to find the LCD of 1 over x plus 1 over x plus 2. So the LCD of that would be, for x, would be x plus, the LCD would be a combination of x and then x plus 2. So the LCD would be x times x plus 2. So we need to multiply that out for each of these. So x needs to be multiplied by x plus 2 on the numerator and the denominator, and then x plus 2 needs to be multiplied by x on the numerator and the denominator. So we have 1 times x plus 2, and then that's over x times x plus 2 plus 1 times x, and that's over x plus 2 times x. So if we evaluate that, we have 1 times x is just x, 1 times 2 is just plus 2 over x plus 2 times x plus 2, plus 1 times x is just x, x plus 2. Alright, so 1 times x is x, and then you have just the same thing as the denominator, x plus 2 over x. And actually, because now we have the same, actually this is going to be step 3. Now, since the denominators are the same, we can combine the terms on the left side of the equation into one fraction, which will be x plus 2 over x times x plus 2 plus x over x times x plus 2. And that fraction will become this right here, which is just x plus 2 plus x all over x times x plus 2. So if we combine the two, we have x plus 2 plus x all over x plus 2. Now moving to step 4, we can go ahead and evaluate the numerator and the denominator. So x plus 2 plus x over x times x plus 2 will just become 2x plus 2 over x squared plus 2x. So right here we want to evaluate the terms on top. So x plus x will be 2x plus 2, and then if you distribute these x with the two terms in parentheses, x times x is just x squared plus 2x. Now our equation is 2x plus 2 over x squared plus 2x equals 1/2, because we shouldn't forget that this whole time the equation was equal to 1/2. We were just ignoring the term on the right side of the equation. Equals 1/2. But now we're gonna move to step 5 and take a look at the right side of the equation. So step 5, now that your equation is 2x plus 2 over x squared plus 2x equals 1/2, go ahead and cross multiply the equation. Remember that a over b equals c over d when you multiply a times d and b times c. So AD equals BC. So multiply 2x plus 2 by 2 and x squared plus 2x by 1. When you evaluate all of this, you end up with 4x plus 4 equals x squared plus 2x. So yeah, right here we're just going to cross multiply. Right here we want to cross multiply. And just like it says here, we need to remember this, that a times b equals c over d. You just multiply across the different terms, which will end up being equal to AD equals BC. So we multiply 2x plus 2 times 2, and then x squared plus 2x by 1. So 2x plus 2 times 2, 2x plus 2 times 2 equals 1 times x squared plus 2x. If we evaluate that out, 2x, 2 times 2, 2 times 2x, we have 2 times 2x, which is 4x, 2 times 2, which is plus 4, equals 1 times x squared is just x squared, 1 times 2x is just 2x, so equals x squared plus 2x. Okay, so now for step 6, we want to put the equation into standard form, which was our initial goal. We wanted to put it into the form ax squared plus bx plus c equals 0. And we can do this by subtracting 4 from both sides. Then we need to subtract 4x by both sides, and our result should be x squared minus 2x minus 4 equals 0. So we want to get 0 on one side. We want to get this into standard form. So to do this, we can start by subtracting 4 from both sides. So you end up with 4x equals x squared plus 2x minus 4. And then we want to subtract 4x from both sides to get 0 on its own. So you have 0 equals x squared negative 4x minus, or plus 2x is just negative 2x minus 4. And right now, this right here, actually let's turn it around. So just put x squared minus 2x minus 4 equals 0. So this right here is our standard form, ax squared plus bx plus c equals 0. Now for step 7, we want to go ahead and plug in the a, b, and c values, a being 1, b being negative 2, and c being negative 4 values into the quadratic formula. So x, which is pretty much 1x, will be our a value, negative 2 will be our b value, and then negative 4 will be our c value, and we want to plug that into the quadratic formula, which is shown here, which is just negative b plus or minus b squared minus 4ac over 2a. So let's start by plugging in the negative, the b value. So we have minus negative 2 plus or minus b squared, and b is negative 2 squared minus 4, a is 1, so 1 in parentheses, and then c is negative 4, so put that in parentheses as well, and all of that's over 2 times a, and a is 1, and actually right here this a almost looks like a 9. It's a little bit sloppy, so let's just clean that up and make sure it looks like an A. There we go. And now going to step 8, we need to go ahead and evaluate the quadratic formula so we can evaluate these values. So negative times negative 2 is just positive 2 plus or minus 2, negative 2 squared is 4. Negative 4 times 1 is just minus 4, and then minus 4 in parentheses, all over 2. And keep evaluating this. We have 2 plus or minus negative 4 times negative 4, because we need to multiply because of PEMDAS, is positive 16, and that's over 2. And then if we keep working on this, we have let me see, we end up with 2 plus or minus 4 plus 16 is just 20, and that's over 2. And then for step 9, the root of 20 needs to be factored and simplified from root of 20 to root of 5 times 4 to root of 5 times 2 times 2 to 2 square root of 5. So 2 plus or minus square root of 20 will factor into 5 times 4 over 2. 2 plus or minus 4 will factor into 2 times 2 times 5 over 2. And then with this 2, because there's 2 of them, we can move it to the left of the radical. So 2 plus or minus 2 root 5 over 2. Now moving to step 10, we can simplify 2 plus or minus 2 square root of 5 all divided by 2. And if we do that, 2 goes into itself once, 2 goes into 2 once, 2 goes into this 2 once. We're left with 1 plus or minus 1 over root 5 over 1, but this 1 isn't needed, it's just redundant, so we can, it's a given, so we can just write 1 plus or minus root 5 over 1, and even the 1 is redundant, we can just leave it like this, so 1 plus or minus square root of 5. And for step 11, we need to remember to write the negative and positive answers for the quadratic formula. So we have 1 plus square root of 5 or 1 minus square root of 5. And finally, for step 12, we want to go ahead and put our solutions in set builder notation. So take out our braces, or also called curly brackets. You put 1 plus square root of 5, comma, 1 minus square root of 5 inside another curly bracket, and that's your answer in set builder notation.